Picture a world without the sounds of animals. That was Earth before the Cambrian period. For billions of years, our planet was quiet. Simple, single-celled organisms lived in the oceans. These tiny life forms were basic but tough. Life stayed simple for a very long time. Then something amazing happened. About 540 million years ago, life on Earth changed dramatically. This time, called the Cambrian period, saw a huge burst of new and different life forms. It wasn't a slow change, it was a revolution, a big bang of biology. This big event, the Cambrian Explosion, is a major turning point in the history of life. It's recorded in fossils, showing the amazing power of evolution. The Cambrian Explosion is one of the most interesting and studied events in the science of fossils. It's a story of new ideas and adaptation, of competition and survival. It helps us understand life itself, challenges and opportunities for life to adapt. The Cambrian Explosion wasn't just about new species, it was about completely new body designs, a radical departure from anything that had existed before. These basic anatomical designs, the blueprints for life, set the stage for all the animals we see today. From the tiniest insects to the largest mammals, the diversity we observe is rooted in these ancient blueprints. During the Cambrian, evolution seemed to speed up dramatically. This period saw an unprecedented burst of evolutionary activity, leading to the rapid emergence of complex organisms. One big development was bilateral symmetry, a major evolutionary milestone. Unlike simpler ancestors, which were often asymmetrical or radially symmetrical, bilaterally symmetrical animals have a distinct left and right side. This symmetry is crucial for coordinated movement and complex behaviors. This body plan helps with movement and is a key feature of most animals today. It allows for more efficient locomotion and the development of specialized body parts. Another important innovation was segmentation, which provided a new level of structural organization. Segmented animals like worms and insects have bodies divided into repeating parts. This segmentation allows for greater flexibility and specialization of body regions. This allows for different body parts to do different jobs and for more flexible movement. Segmentation is a key feature in the anatomy of many complex organisms. The Cambrian period was a time of amazing evolutionary experiments. It was a crucible of innovation, where nature tested countless new forms and functions. Many of the body plans from this time were very successful, forming the basis for the major animal groups we see today. These foundational designs have stood the test of time, evolving into the myriad forms of life that inhabit our planet. The Cambrian seas were full of strange and wonderful creatures, unlike anything alive today. This period, known as the Cambrian Explosion, was a time of rapid evolutionary development, leading to the emergence of many unique and bizarre life forms. One of the most famous was Anomalocaris, a scary predator. This creature was one of the largest of its time, reaching up to a meter in length, which was enormous compared to its contemporaries. With big eyes, grabbing arms, and a circular mouth with sharp plates, Anomalocaris was the stuff of nightmares. Its eyes were among the most advanced of its time, giving it a significant advantage in hunting, but Anomalocaris was just one of many interesting Cambrian creatures. The Cambrian seas were teeming with life, each species playing a unique role in the ecosystem. Trilobites, with their three-part bodies and hard shells, are probably the best-known Cambrian animals. These creatures were incredibly diverse, with thousands of species identified by scientists. These adaptable creatures lived in lots of different ocean environments and evolved into many forms over millions of years. They were scavengers, predators, and even prey for larger creatures like Anomalocaris. The Cambrian seas also had early versions of other animal groups, including worms, sponges, echinoderms, and even early chordates. These groups would go on to evolve into the diverse array of life we see today. The chordates are particularly significant because they are the group that would eventually lead to animals with backbones, including us. This early stage of evolution set the foundation for the complex life forms that would follow. These creatures, though strange to us, represent the early stages of life's diversity, a time of evolutionary exploration. The Cambrian period was a crucial chapter in the history of life on Earth, showcasing the incredible adaptability and resilience of life. We know so much about the Cambrian explosion because of incredibly well-preserved fossil locations called Lagerstätten. These special sites are like time capsules, capturing moments from millions of years ago in stunning detail. These sites, like the Burgess Shale in Canada, preserve not just the hard parts of animals, but also their soft parts, giving us a rare look into the past. The level of preservation is so exceptional that even the most delicate structures like gills and digestive systems are visible. The Burgess Shale was discovered in 1909 by Charles Doolittle Walcott, and it's incredibly important for paleontology. This discovery opened a window into an ancient world, providing insights that were previously unimaginable. The fossils there are preserved in amazing detail, showing the delicate anatomy of soft-bodied creatures that are rarely fossilized. This includes creatures like the enigmatic Hallucigenia and the predatory Anomalocaris. These fossils have helped scientists reconstruct the Cambrian ecosystem. By studying them, researchers can piece together how these ancient creatures lived, interacted, and evolved. The Burgess Shale tells a story of an underwater world full of life, a complex and diverse ecosystem unlike anything before. It was a time when life was experimenting with new forms and functions, leading to the incredible diversity we see today. It shows how amazing fossils are for understanding the past and how dedicated paleontologists are to piecing together the story of life. Their work helps us appreciate the complexity and beauty of our planet's history, reminding us of the ever-changing nature of life on Earth. The Cambrian explosion is still a fascinating and debated topic in evolutionary biology. While fossils show this rapid diversification of life, the exact causes are still being researched. Some scientists think a sudden increase in oxygen allowed for larger, more complex organisms. Others point to changing sea levels, moving continents, and new habitats as key drivers. Still others suggest that things like the evolution of predators played a big role. Predators would have forced prey animals to evolve defenses like hard shells, leading to an arms race of evolution. It's likely that many factors, both environmental and biological, caused the Cambrian explosion biodiversity we see today. The Cambrian explosion was a key chapter in the history of life. It was a turning point, a change from simple, single-celled organisms to complex, multicellular life. Cambrian fossils give us a special look into this time. The Cambrian explosion shows us the amazing power of evolution to create new and complex life quickly. It also shows how connected life is, how changes in the environment can have huge and lasting impacts on evolution. As we continue to study fossils and the Cambrian explosion, we learn more about the history of life on our planet. The Cambrian explosion wasn't just something that happened in the past. It was a crucial step in the journey of life, a journey that continues today.